Our presenter for the time slot 12:20 is John Minier. He is from Johannesburg, Michigan, and will be sharing with us his capstone project, the KLOTSKI kitchen solution. Please join us in welcoming him.
All right. Thank you for that introduction. My name is John Minier, and I'm here to present to you my capstone project, the KLOTSKI kitchen solution. So what is the KLOTSKI kitchen solution? Well, the KLOTSKI kitchen solution is a system I've created to challenge how we approach kitchen customizability, modularity, and how to keep it updated. It's loosely inspired by the KLOTSKI puzzle game. The KLOTSKI is a puzzle game I found that involves sliding blocks around in a space in the attempt to move one particular block to a goal. In the pictured example here, the goal is to move the orange block at the top to the opening down in the bottom without removing any blocks from the puzzle. So what I'm going to talk about next is the problems of the modern kitchen. And then we're going to go through some of my ideation process to solve those problems. And then we're going to talk about how I arrived at my latest iteration in solving these problems. Then we're going to talk a little bit about how it's constructed. And then we're going to look at examples of the possibilities that this project opens. So, first thing, what are the problems? First thing I did was I jumped into research to try and figure out what kind of costs were involved in the kitchen's construction and renovation. This led me to determine several weak points in the kitchen structure, mainly these three. Many people update their kitchens every 10 to 20 years, and it often involves a massive time and monetary investment. Second, appliances and cabinetry are often limited to their given place after construction. And third, there's no overall flexibility with layout or materials once it's constructed. So it's mainly these three issues that I wanted to focus on at the beginning. First, the kitchen is expensive to update and maintain. Second, it is behind many other spaces in evolution. And third, there's very little users can do to customize their kitchen easily. So, looking at the first problem, the kitchen is expensive to update and maintain. The cost of a kitchen remodeling can be anywhere from $20,000 to $120,000, depending on what you're doing with it. So largely this will depend on what you're replacing or building. So if you're going to remove all the cabinets and replace everything, remodel the entire layout, that's going to cost you a lot in effort, time, and money. So the second problem is behind other spaces in evolution. Technology has become a major part of home life. It gets into more and more parts of the home, and it becomes part of our everyday lives. So the kitchen is one of those spaces that has the most potential for that technological innovation, but no one's really like playing with it very much yet. This is a complicated space to add technology into. It's really hard to know where to even start with all this. So generally, companies are playing it pretty safe and only doing small things to see how they can add technology into the space, such as the Samsung Smart Fridge, which is essentially introducing smart tablets on the face of it. And then the third problem, customizability, is difficult, time-consuming, and expensive. So we kind of talked a little bit about this with the first problem. But once you get everything remodeled, it's there to stay. There is rarely anything you can do to move things around and start playing with different ideas. So your layout is pretty much stuck the way it is until you get to the next time you want to renovate everything. So how did I approach solving these problems? First, the cost to update. How do I make the kitchen easy to update with lower cost and easy installation? Evolution. What is the future of technology in the kitchen, and how is it going to improve? And third, customizability. How can a kitchen be customized easier in a simple, approachable way? My ideation began with the boring stuff, really, getting standard measurements. In order to push the limits, I really had to know most of them before I could get there. Fortunately, a lot of measurements are really pretty standard. Counters are about 24 inches deep, and they sit about 36 inches off the ground. There's an 18-inch gap between counter and cabinet, usually sticks to about that measurement. It can go a little lower. But those kinds of measurements are very standard and very easy to find. So it was at this point where I began to understand how I could apply the idea of the KLOTSKI puzzle to this situation. By splitting the kitchen into smaller portions, like the blocks in the KLOTSKI puzzle, I could make an easy way to customize the kitchen. So, using my measurements, I began experimenting with splitting cabinets and appliances into chunks. This presented several challenges. Theoretically, it allowed for a lot of flexibility with layouts and allowed for users to make changes quickly, kind of sliding the puzzles around like the puzzle, or sliding the cabinets around like puzzle pieces. But without developing these simple dimensions for how big the blocks were, I couldn't make it fit in a very modular way. So you can see in these two highlights where I was ideating on those measurements and trying to figure out a real standard. So in that standard, I set up 3 basic widths going off of 10-inch increments. The smallest width, 20 inches, I set up as mostly single cupboards. The intermediate width, 30 inches, I created specifically for more flexibility. Many appliances, such as stoves or microwaves, are about 30 inches wide. So this allowed cupboards and appliances to go right next to each other in a vertical manner. And finally, the largest size I created was 40 inches, which really allows for the most space. And these are typically this is right about how big a lot of large cabinets are anyway. It also manages to match the general width of a lot of fridges. So after determining measurements, I turned to playing with layouts. A well-designed kitchen should enable users to have space to work as well as provide a seamless flow between different stations. Kitchen design is based on that flow. One way this is explored is through the kitchen triangle, which you can see in the top right highlight. The kitchen triangle exemplifies the flow from a fridge to a sink and then to the stove. It wasn't until I understood the kitchen triangle that I realized how important it was. Not only was it important for understanding how kitchens were arranged, I realized how my system could help facilitate more personalized setups. With a kitchen that can be rearranged at any point, every user can have a flow built to their own needs. So if you need more counter space next to the fridge, you can do that. If your dishwasher is too near the sink, you can move it over. Or even if your stovetop is too far from the sink, you can move that closer. Realizing all of this, I slowed down to dive deeper into how my many parts could actually fit together. Here you can see how I was working out how to keep the wall cabinetry actually on the wall. As I had to split the wall cabinets into blocks as well, they needed a flexible system that could afford all the unique arrangements that an individual could create. But it still needed to be able to hold a decent amount of weight. You put a lot of things in those cabinets, from all the kinds of containers that people have. This meant it had to be screwed into the studs in the wall, which is a unique challenge, as studs are generally either 6 or 8 inches apart. instead of the 10 inches that my system uses. My first idea involved electromagnetic connectors between wall inserts and the cupboards, but I quickly pitched this one as a little bit far-fetched. Not only did it not work well with real standards, but if the electric flow was ever interrupted, such as in a power outage, everything would just fall off the wall. It's a bit of a mess. My next idea was for retractable wall hooks, but it wasn't going to work with the wall studs and the 10-inch spacing that my cabinets required. The idea I ran with involved putting hooks into the back of the cabinet and then hooking those into a simple wall-mounted rail. With that portion of engineering covered, I began playing with how the lower portion of the kitchen would work. This meant pulling apart the entire thing and planning out what parts I wanted to be easily interchangeable or removable. As you can see here, the counter remains mostly solid, but the drawer and the cabinets dissect really rather easily. Handles, doors, and even the drawer face can all be replaced, allowing for users to change out one style for another with only a few minutes of time involved. One small challenge was how the countertop, drawer, and cabinet would actually fit together and remain firm. If I made the tolerances too tight, then they wouldn't slide together very easily and manufacturing would be more expensive. So I had to create a way for there to be low tolerance, or rather high, whichever one. I needed more space, so I needed some way for the tops and the bottoms to really be able to hook together and then tighten together. My solution was to have male and female parts between the drawer, countertop, and the cabinet that when inserted, these parts could be tightened down with this mechanism, which is actually very similar to how a scooter handle is actually tightened. So it's a simple and easy way to operate, but it's also compact and reliable. Finally, I worked on some ideas for appliance integration and technology advancement. Many of these could become projects all on their own, such as this idea for a stovetop that uses sensors and induction heating to only heat certain spots on a surface. So specifically, if you placed a pot onto this surface, it would sense where that pot was placed and then heat only that area rather than the entire space. Or ideas for these seamlessly integrating tablets, outlets, and other helpful appliances right into the countertops. And then finally, I was experimenting with ideas for advanced appliances that could also work seamlessly with the KLOTSKI system. So finally, before moving into CAD work, I started sketching out some refining sketches so I could have a clear picture of what things were going to really look like. You can see several of them right here. So finally, and we're getting into some of the renders I did. And here, you can see all of my 40-inch size sitting countertops and cabinets in a wide array of materials that can really show how diverse this kind of kitchen can really be. For simplicity, we're going to stick with this one. It's a simple wood base with brushed aluminum handles and a stone countertop. We're going to use this one as the material choice for the rest of the presentation. But we're going to start breaking this down to really show how all of it works. First, we can see how the three parts of the cabinet pull apart. So you have the cabinet space on the bottom, the drawer above it, and then the countertop piece on top. And now you can kind of see how all of these are going to be constructed. Minus the screws, there are only about 23 parts, and it's really easily disassembled. Handles are easily inserted into the drawer face and the door, and then it's just held by a couple screws. Handles are also the same size, no matter what door or drawer face they're put in. So you can really exchange these to wherever you want them, and you only have to buy one type. Oops, my bad. The drawer face and the doors aren't quite as universal, but the 40-inch and the 20-inch cabinets share the same size door, making it easier for manufacturer and user exchange. I also remembered to shape the bottom edge of the cabinet so that it could have feet on it. While installed cabinetry doesn't have to worry too much about level flooring, this system needs to remain steady, and feet are much better at providing that. So now moving on to the hanging cabinets, we can see a few differences. First of all, there's no drawer, countertop, or feet for obvious reasons. The metal piece you can see down there is the wall railing that this cabinet will hang from. I kept it really simple so the railing can be made as long or as short as you needed, just to accommodate more pieces that can go on the wall. And once again, you can see how easily this pulls apart into just 10 pieces minus the screws. Now, you can see how this system looks like as a whole. We'll say that this is the kitchen setup as it first comes to a young couple that's just moved into this home. You can see on the left side, the oven and the stovetop under a wall-mounted microwave. And to the right, you can see the fridge and the sink behind the island. Notably, you can see how there are two heights for the hanging cabinets, a taller 30-inch one that we just looked at, and a shorter 15-inch one. This allows for a great deal of room flexibility, as now you can put something like the microwave or the fridge below some of these cabinets. They need a little bit more space. And then here, you can see how everything can be rearranged very easily to better suit the growing family that's using it. Most notably, you can see the peninsula extension on the left side. You can see the fridge's new place on the left next to it, leaving a roomy workspace over on the right where it used to be. And then you can see here how the stovetop has been swapped with one of the countertops and the island, leaving the microwave and the oven where they were last, but giving the stovetops more space around it out on the island. In this final rearrangement, the family living here has gotten old, and as age sets in, so does the inability to move well and bend over. To combat this, most of the main appliances have been moved to counter height. So you can see the fridge and the freezer, which were once stacked on each other, are now split. Freezer on the far left, fridge on the far right. Between them, the oven and the dishwasher have been stacked, leaving the cooking range out on the island, which has been again shifted to a new orientation. So, as of this iteration, there's much that my system can't do yet. This list shows some of the main things that I can work on in the future, but I think the system has a great deal of potential, just seeing how large this list really is. So like the list given here isn't at all a list of failures, but instead is a checklist of incredible ways I can expand and develop this into the future. So thank you for your time. If there are any questions, you may text them to the number on the screen, and I will gladly answer them. Thank you.
Thank you, John. A few questions right here. With the rail system, do the hanging kitchen cabinets hang at an angle, or how are they kept flush to the wall?
Yeah, so I wasn't able to show this. I'll go back a few slides. But when modeling this, it didn't work out quite right. But there are small, like rubber feet almost on the back here. And those essentially extend the same width that this does. So they rest against the wall. It's also what helps keep the entire system from sliding back and forth. So instead of just sliding of its own free will, if you accidentally push in one direction too hard, those rubber feet will actually stick to the wall and provide enough rigidity to keep it in place. So yeah, good question.
Okay, next question. Curious about the electrical and wiring. Is that something you've thought about?
Yeah, it's something that's definitely, actually, I think it's on the list of things that I'm going to do in the future, especially as I try to extend this into having tablet or outlet installation in some of the countertops. And then as well as I try to mess with smarter fridges or microwaves or other appliances. Wiring isn't something that I was super concerned with just getting the system put together as a whole yet, but there's a lot of clear potential for it yet.
What do you think the most challenging part of this was?
Definitely getting all of the measurements right and then making sure that things could be so easily exchanged or switched around with each other. Because it's really not easy to set up a system as complicated as this. Because it can look really simple as soon as you're done making it. But just like starting out and trying to figure out how am I going to build this from the ground up is incredibly complicated but also very fun.
Excellent. So how could your system address ADA compliance with vertical heights of counters and wall cabinets?
I hadn't thought too much about it, mostly because I didn't know enough about those. It's definitely one of those things I can look into in the future. Like there's not, especially as I continue through later iterations, it's something that I can consider more. But for the sake of this presentation, I had mostly focused on keeping this is what it could look like. So it's less of a tangible, this is exactly how everything's going to work.
Excellent. Have you considered how easy your modular pieces are to clean? For example, there are a lot of gaps in between pieces. You might need to move things around to clean them properly.
Yeah. So that's something like I did keep like a little eye on. Mostly, again, it wasn't like super focused on like just trying to like set up the system. But I did try to keep an eye on the materials. So materials could be easy, is one area to clean, but like keeping things moved around and keeping them clean under. I suspect it's going to be easier with this than how kitchens are set up now. So like right now, you can't even get under any of those spaces. So they're probably a lot dirtier than you expect them to be. So often people can't even like move their ovens out and just like get to cleaning all of the crud that falls between all the cracks there. So I think this system really can help you be able to move things out and clean under them, as opposed to having all of the firm rigidity of the kitchen nowadays, where you can't even get to any of the space easily.
Okay, this is a similar question. Are the countertops modular, or are they a part of each cabinet? If they're modular, then how are the cracks in the countertop addressed?
Yeah, so there's not a whole lot you can do with countertops yet. That's one of the things I'm going to look into in the future, is trying to extend some of that. The cracks is definitely an issue that I'm concerned about right now. So like if I were to pick one concern with this system because I'm really good at picking out things that I don't like about my own projects, it would probably be the cracks between these pieces. So in my mind, it's a little bit of a trade-off. You get a lot more flexibility and there's a lot more you can do with this system. But there is that. You're going to have to get used to the idea that there can be small cracks.
Okay. How do the gas, water, and electric connections for the stove, sink, and refrigerator fit in with the modularity of the rest of the kitchen?
So far, the only thing I haven't been able to figure out how to move around is the sink. So I would probably make that a project all on its own, is how I can make the sink able to move around like the rest of the pieces. So right now, that's just installed where it is, and I can't do much about it. But I can very easily like work out some ideas for how I can make this work.
Good. We have one comment. I love this kitchen idea. Great renders, John. So good job on that. Great work. Flexibility is a great innovation. Is this concept similar to IKEA's rail-mounted modular system?
Actually, yeah, they were an interesting inspiration. So I didn't get to look too much into what they did exactly, but I did actually spend some time researching like how IKEA does kitchens in the first place. So they were a very interesting inspiration.
Is there a reason the dishwasher was not raised to the counter level in the last version?
Mostly, I just didn't know where to put it. So by that point, I was like trying to get together the final render, and I wanted to keep it simple, so I didn't want to take up all the counter space. So I mostly put it there. It should have gone on the counter, like I agree, but I also wanted to keep it like looking a little cleaner for the presentation, so I stuck with that.
Good. I see you have part of the hanging mechanism exposed. How do you propose users utilize this exposed section?
Yeah, so that's one of the other future things I can do with it is adding more appliances that actually work with the system. So I think I had some ideation that I showcased earlier in the presentation. But essentially, if you can have some exposed railing, then it's my hope that you can actually have some appliances to work with that space as well.
Great. Okay. I am now going to hand it over to Carlos for some comments. Carlos?
Thank you, Gabe. John, I don't know if you mentioned it before, but how much weight the hanging cabinets on the walls can take, or have you calculated?
That would probably require some actual like physical testing to be sure. Yeah. I am aware that this is like the wall railing isn't a super new thing. In fact, many microwaves that are mounted above like a stove range actually use a very similar mechanism where they're just wall mounted. They're nailed to the studs.
Okay. All right. And at what point your creativity phase became more intense or challenging, or it was present all the time?
It really had to be present the entire time,
Mm-hmm.
especially in the ideation phase where I was trying to get all of these ideas on paper, but then also try to set up a system that worked well with itself.
Okay. And how easy or difficult was the experience of moving from the ideation sketches phase into the actual computer drawing and modeling space?
It wasn't a very difficult transition, mostly because I had set up a lot of the measurements ahead of time. So I had most of like a good idea of what I wanted to do in CAD before I actually got to it.
Okay, great. And the next question, you partially answered when you talk about IKEA, but I was wondering if in your research, did you find other companies that already offer this system or something similar to what you are doing?
No, actually, very few, if anyone, is really doing something like this. So I suspect IKEA is the only one that is really messing a little bit with how people can personalize their kitchen.
Mm-hmm.
So I don't think anyone else is really doing this.
Great, good, great job, John. Thank you.
Thank you.
Sure. Thanks, Kay.
Thank you, Carlos. John, fantastic work. Well done. Everyone, please join me in congratulating him on a job well done.